All right, so we're starting with number 12. It's kind of nice in this one. They give you lots of background information. So even like if you had missed everything on frame of reference and relative velocity, you had kind of like a half-page notes there about it to help you. That's kind of nice of them. But we have these 4 cars, actually 5 cars, and they're all moving, and we keep switching frames of reference. So we'll start off number 12, and so our y should show our understanding of relative velocity and frame of reference. So let's see. How about each car's velocity depends on the frame of reference. Thus, the speed and direction of the cars will change when the observer changes frame of reference. Okay. Now there's nothing, if I look at my rubric though, nothing I've put in there that really links it to this specific problem. Oh, I could talk about the Etzel in the problem, right? So that's kind of unique to this problem. How about since only speed is given for car E, it can be going in either direction. So let's see, did I show a clear understanding of the physics in the problem? I think so. That sentence I just added sketches the roadmap to the how. So that's providing a direct link to this problem, so it's not all just generic platitudes. And I explained why the universe works, not how to solve the problem. All right? What do you guys think? Did I hit my rubric? I think so. So now we can move on to the how part. And I put the rubric for the how at the top. I think I'm going to grab a couple things just to make life easier, like that diagram they gave me, maybe the equation sheet. Maybe grab this. And grab my equation so I don't have to retype them. All right. So, let's see. So they asked the first question, consider a statement. what frame of reference do you think that's in? Guys, if you're not interested in this problem, we'll just say we're done, move on, go to the next one. I mean, I don't want to bore you, but so if you are into it, I'm glad to continue it. But if you're not, let's do something better. So let's try. Which frame of reference are these the figure measured in? Do you think? Okay. I think we can go with that assumption. Right? Good. So that means if I go back here, and I look at these values that they've given me, which way do you guys want to call positive? To the right? That way? Okay. So that means this is the velocity of A with respect to the Earth, which is positive 12 meters per second. This one would be the velocity of B with respect to the Earth, which would be 0. This would be the velocity of C with respect to the Earth, which would be negative 15 meters per second. And this would be the velocity of D with respect to the Earth, which would be negative 20 meters per second. Good? Yes? No? All right, so then they want me to find things like what is V, A, what is the velocity of A with respect to B? So, I want this. So part A, or B, excuse me, velocity of A with respect to B. Now notice they put a slash in there. I leave the slash out. It's one more thing to type. I'm thinking of using that top equation. So that would mean I need the velocity of A with respect to something plus the velocity of something with respect to B. And those two inside things have to be the same. Oh, I know the velocity of A with respect to the Earth. And then I could get the velocity of the Earth with respect to B. Because velocity of the Earth with respect to B is the negative of the velocity of B with respect to the Earth, using that second equation there. What is the velocity of B with respect to the Earth? 0. So what's the negative of 0? 0. It's kind of freaky. So I could plug in here now and solve, right? So I would have, let's see, positive 12 meters per second plus 0. I'm pretty confident you guys can get that answer. If you need to borrow my calculator, it's right up front. Okay. I'm not going to tell you. That'd be like telling you all the answers. Let's see, what else do they want us to do? Whoops. I'll hit the right button sometime. That's part B. Part C, velocity of B with respect to A. Oh, we can do that, right? Because we know that second equation. So this would be part C, velocity of B with respect to A would just be the negative of A to B. Do we know A to B? Yeah, because we answered part B. Excellent. That part's done. Let's go on and look at D and E. Can you determine the distance between the Audi and the Buick? Do they tell us anything about distance? No. So usually if they don't tell you anything, you can't figure out anything. Velocity of A to C is part E, right? So that was A to C, right? Yeah. So let's see. So this is part E. Was it D or E? E, I think, right? Because D was that yes or no question. So I want the velocity of A to C, of A with respect to C. So why not do the velocity of A with respect to the Earth plus the velocity of Earth with respect to C? Right? And I'm confident you guys can do the algebra for that. This is going easy. F, D with respect to C. And then G is C with respect to D. So, D with respect to C. So, F. Velocity of D with respect to C. Why don't we do D to the Earth plus the Earth to C. Oh, that'll work. And then the next, then G, right, is just CD equals the opposite of DC. And then we get up to H, our last part. Whew. So car E, Edsel is moving along. Know the point of view of the driver of the Audi. The Edsel is moving at 8 meters per second. So that would be E with respect to A. Oh, we got to say that differently though, because we've been using E for Earth. We could. I'm going to call it M for mystery car. Because I can call it whatever I want. And then they want to know what is the mystery car relative to the odometer. So, they tell us, get some new space here. They tell us the velocity of the mystery car to the Audi is either plus or minus 8 meters per second, right? Because they don't tell us direction. True? Oh, good, because that was back in our Y, right? And if it wasn't true, we'd have to go back and change it. And they want to know the velocity of the mystery car to D. So if we did the velocity of the mystery car to D, that could equal the velocity of the mystery car to A plus the velocity of A to D. Didn't we figure out A to D someplace? Or we haven't? I can't remember. Oh, I guess we didn't.
We didn't.
So we would have to do, let's a little side here, velocity of A to D would equal velocity of, I'm going to say A to the Earth plus the velocity of Earth to D. Oh, I know A to Earth. I know E to D, right? Because I know D to E. And it's just the reverse of it. Yes? And so I can figure that out. The only tricky part here is MA. We don't know if that's positive or negative. So I have to do this twice. Once when I do it with positive 8 meters per second plus VAD. And the other time with minus 8 meters per second plus VAD. So it's really H that is the trickiest part of this one. Yes, sir?
0 or 7?
Well, 7 wasn't one of the ones highlighted, so if we get through all the highlighted ones from the do now, then gladly we can go over 7. Right. Any other questions on 12 before we move on to 10? We're good? All right. All right, so number 10. We have a dog running with this. It has the momentum of this. What is the inertia of the dog? Remember, whenever they say mass, what they really mean is inertia. They just don't want to scare you with big words. Oh, they've been nice. They gave us all base units here. Meters per second, kilogram meters per second, and then kilograms. Goody. So, number 10. Momentum, right? So I want to show I understand momentum. So momentum is inertia in motion. The velocity, I'm trying to go quick because I see our time's running away, describes the motion as a vector. So momentum and velocity have the same direction. And then I would need to look at this one and say, okay, I need something to tie to this problem. So the more inertia the dog has, the more momentum also. Probably should have reversed that. The more momentum, the more inertia the dog has. Probably should have the way the problem set up.
So on Thursday, we have to have all the Y, or all the
I'm kind of in the middle of this. Could we hold it until I finish this problem? But remember the question, because I think it's going to be a good question, but let me finish this problem first before we go over procedures. All right? Any questions on the why? All right. Let's go and do the how. So if I look at my equation sheet, I find that I have an equation that says momentum is inertia times velocity. And in this case, they don't really give me a direction. They tell me a speed. So I know that the two are in the same direction, so I'm going to drop the direction from my equation. And now it's just substituting in, right? 20 kilogram meters per second equals the inertia times 1.6 meters per second. Now, a very common mistake is to use my numbers rather than your numbers when you're solving your own, because we should have different numbers. So be careful of that. I always have a bunch of people say, it didn't work. I said, well, did you try yours or my numbers? And they said, your numbers. And I said, okay, well, that's why. And so I get 12.5 kilograms, which, let's see if this works in my rubric. I started with valid physics equations. I hope I applied the correct ones with units. I substituted with units. I hope my math is correct. It seems right, and I used units in it. Correct numerical answer, including scientific rounding. That was exact, so I didn't have to round it. Correct significant digits, which for me means 3. So that's 3. And correct units in the answer. So it looks like I think I hit my rubric. Let's see if I got it right. Now, this is where again, another feature of this program I'm not in love with. They want 2 sig figs, including appropriate units. And knowing them, they want me to round up rather than rounding to the evens, which I should do. Yep, that's what they wanted. So they wanted 13 because it wasn't written by physicists, these problems, unfortunately.